Hey, Lauren. And let me. All right. Okay. Okay, I'll be right back. Hi, everyone. You all hear me?
We can hear you.
Awesome. Thank you. All right. Welcome. Hope everybody had a nice long weekend. Let me bring up the chat and put it on the side. If you have any questions, please leave it on the chat. And let me just hide this floating control. Okay, excellent. All right, welcome. So this is the, we're getting started on the 5th week of designing databases. And so we've been covering quite a bit, right? The first week we installed a database, taught you how to do some really simple creating new tables, inserting, updating, some really simple stuff. Then we looked at how to design databases using UML class diagrams and how to make sure that the databases were normalized, and we were avoiding any inconsistency by limiting any redundancy. We talked about how to actually create those databases once you've designed them using the create statement and relating tables in using the relational model. Last week we spent some time asking ourselves, well, how do we retrieve data? Once data has been stored there, how is it that we retrieve from a single table, from multiple tables? And if you have the data all spread out over multiple tables, how do you that you retrieve all that? And so this week we're going to be spending some time on actually populating the database, right? So how is that data made it into database in the first place, right? So we'll talk about how to insert into the database, how to update data that is already in the database, remove it, and with that, we'll conclude the major types of operations that we can do with a database, which are usually with any data source. We have 4 basic operations, right? Which sometimes are we use the acronym CRUD, right? We want to be able to create, we want to be able to read data, update the data, and delete the data. So we use the CRUD acronym to say that those are the 4 basic operations. So with that, this week and next week, we'll be wrapping up some of the most basic things that you can do with a database, and then we'll be moving on to some more interesting things, such as how is it that you can program the database, how you can run functions and triggers and things that are getting more and more exciting. Let's see something on the chat. I noticed the quiz answers are still locked. Will these be unlocked? Yes, I will unlock them today so you can take a look at them and get some feedback from there. Yes, thank you, Juliet. Yeah, so So just a couple of administrative things. Let's see. I did modify the calendar just a bit. We originally had the midterm coming very, very soon, and so I moved it 1 week later. Right, we had it week number 6, so that would have been like at the end of next week. So I think that's way too early. I know the dates have changed, shifted a little bit. The whole semester has been compacted by 1 week. We there's no vacation week this semester because of COVID. So yeah, so I moved the midterm exam to week number 7 as opposed to week number 6. Okay, so we'll have one more week next week to do some more content. We'll talk about programming the database starting next week. And then the week after that, we will have the midterm exam. Like the quizzes, all exams are going to be asynchronous, right? So you'll get the just like the quizzes, the exams will be made available at the end of the week, early that day, and then they'll be available throughout for 48 hours, right? So anytime between there, you can choose to take the exam anytime that is convenient for you. Okay, so yeah, they're not going to be during class time, so you don't have to come physically, even remotely or virtually to class to take the exam. They will be available for 48 hours at your convenience. The material will be everything we've covered so far. We probably won't do programming for the midterm, even though we'll cover the material. We won't, there'll be an assignment that'll go out for programming the database, but since you won't have any feedback yet, we're not gonna do that. We're not gonna have that for the midterm. It's a little bit too close to the midterm. Will we get a practice test or study guide? Yes, we will take. There's the day before or the lecture before the midterm. We will go over all the material. We'll go over some sample questions, and we'll create a study guide for everybody. Okay, that I'll then share with the class. Anyway, so that's the change there. After we come back from the midterm, we'll continue and do some more advanced topics. We'll talk about how is it that we can map our database to an object model. How do you map a relational model to an object model? We'll do some one lecture on web programming, on how is it that you know now that you have a database, how is it that you interact with it? How can you build an application around that? We'll do some really simple, get you going with a really simple web application driven by the database, and then we'll come back and do some optimization and NoSQL. All right, so that's the plan for the next couple of weeks. Any questions? Okay, no questions. All right, let's see. So the upcoming assignment is going to still be working with the database that we've been playing around for the last couple of weeks, almost more than a month, which is the kind of like a social network blogging application where you have users that can have many blogs, and each blog can have many posts. And then folks can either reply to a post, right? And those are hierarchical. So you can have nested replies, a reply with a reply, and then folks can rate your post, either thumbs up, thumbs down, or give it a score. So we're gonna keep at this database, for the remaining, for the foreseeable future. We're gonna stay within this theme, and so we're gonna be learning on how to obviously import databases. We've done this before. We'll get a chance to practice that again. And then what the focus is for this week is that we're going to be learning how to add data, create records into tables that we've designed and we've implemented, as well as being able to update or remove records from there. We are going to be still using the same database from last time. This is a database that I had that I've exported and then I've made available to you, and you can download it from here, right? So for this assignment, you'll download this database and you'll start all over, right? I know you already have a database that you might have worked with for the previous assignment. This is going to override that database, right? It's just gonna drop all your old tables, right? It's gonna recreate the tables and reinsert the new data in there. Okay, so and it might be a slightly different. There might be some tables in there that might not be relevant to the assignment, but nevertheless, also the names of the fields might have changed a little bit from the last assignment. So this guarantees that everybody's going to have the same database, right? And everybody's working with the same data. Nevertheless, if there are slight modifications, maybe the IDs might not be the same. Maybe the IDs that I'm using, ID 1, 2, 3, 4, 5, but yours might be, I don't know, 5, 6, 7, 8, and 9, right? So be aware that that might be the case, that the IDs don't match exactly with what you might see as you work through this assignment. That's fine. If you need to change the IDs for some of the queries that we're going to be using, if you need to change them, that's fine, right? If the ID number 5 or ID number 2 that I'm using in this example doesn't quite work for you, you are free to make those changes for these queries to indeed be successful. Okay, so let's I'm going to as always, right? We're going to demo what we're giving you for this assignment, and then leave up to you to replicate or to on your own, right? Go on and do something similar to what we are doing, right? What we demo. So first we'll download the database, right? So this is the database. I'm going to download it, and here I'm going to click on download. There it is. I'm going to click on it, and it'll create a directory. There it is. So the directory is DB Design 4. I've done it several times. So in here, you'll notice that there's several tables, right? That are created brand new, right? They drop the old tables, they create the new tables, and then they insert new data into these new tables. If you open it up, I guess it's opening all of them. Let's see, where did it open them? Oh, no, not Sublime. Let's open users. I'll open it with Workbench. There it is. So this is the database that I exported, and then I'm giving it to you, right? Which is basically dropping your old users table, creating the users tables brand new, and then inserting users such as Alice, Bob, Tim Dodd, right? Elon Musk, Charlie Brown, right? All these users have been added. So this is going to blow away whatever tables you had from your previous assignment, and it's going to recreate a brand new, right? Again, this is going to guarantee that everybody's working with the same base database, right? That if somebody might have made some slight modifications to the previous assignment, then we don't want to carry over this and then having everybody work with something different, right? So this guarantees that everybody has the same thing. All right, so let's import that. And you can import it as the instructions walk you through this, right? The instructions say, well, go to in the main menu, go to server, data import, right? Go to import from dump project directory and then start import. So let's follow those instructions. You go to database, servers, data import, and then you can navigate to that directory we just expanded. That's on the downloads, and it's this one, right? And we're gonna say open, and then we click on start import. So it's gonna destroy our old database, right, and recreate it brand new. And let's close that, and you can refresh to see if everything's still there, and you can see if the users are there. Okay, there we go. So Alice, Bob, Tim, blah 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 blah. They're all there, right? So this data has been populated. Okay. All right, excellent. So let's we can get started with the assignment. Again, I'm going to demo my part, right, and then ask you to do it on your own. Right, try to do it on your own. So Right. So the first part of the assignment asks, gives you a chance to practice the use of inserting data into a database, right? And it goes through several ways of doing it. One of them is being able to insert into specific columns. Okay, so this is the syntax on how is it you can insert into specific columns. You can say insert into the table name that you're inserting, the specific columns that you're going to insert, and then the values for each one of those columns, right? So that's a very common syntax. And so to practice, we're going to insert a couple of users, right? So first of all, we can look at so we ask you to create a new SQL file, right? And you're going to be doing all your work here, right? So if you paste that in there, make sure that you copy and paste, including the comments, right? Also, if you write any of your queries, please add your comments explaining what does that query do, right? So I'm going to copy that. I'm going to paste it in there, and then we can execute it, and that just returns just all those users like we saw earlier. Okay, and then we're going to insert a new user. We're going to insert Edward Scissorhands. Right, so we click on that and then just paste it in here. And if we run this insert, if we look at the syntax real quick, right? So it's insert into the table, then the columns, and then the values. And the values are for those columns, right? So Edward for first name, Scissorhands for last name, Edward for username, and password for password. Okay, and then you can just run it. You can just select it and run it, and presumably has inserted that that new user. So let's insert now Frank here. Let's insert Frank Herbert. He's the author of the Dune movie that's coming out later this year. It was supposed to come late last year, but it was postponed because of COVID. And I'm looking forward to that movie. So anyway, so if you run it, right, presumably it has inserted the 2 users up to this point, right? We can retrieve all the users to just make sure that indeed we have the users. Right, let's run it and notice that indeed we have inserted Edward and Frank. See that? Let's see. Yeah, very hyped. Will we get a practice test? Yes, you will. Yep, very hyped for that movie. All right, excellent. So let's keep going. There's another alternative syntax where you can just skip the names of the columns, right? So for instance, you can say table, and you don't have to specify the columns like we did here, right? Here we specify the columns. But this other syntax is slightly different. You don't have to specify the columns. So the question is, well, how does it know that these values are for what column, right? And the answer is that it looks at the original description of the table, right? And it's going to assume that these values are in the same order as the columns when they were defined, right? So if you insert value 1, 2, 3, then it assumes that you're talking about inserting for column A, B, C. Okay, so in the same order. So you have to make sure that when you provide these values, right, you know that, right, that the first value is for the first column, and so on and so forth. It needs to be of the same data type, right, and in the same order. So obviously that creates some things you need to consider. Well, what if you don't want to provide the value for a specific column? You don't have a value for for that column. Do you just skip over it? Yeah, you can't skip over it, right? So you need to provide null. Null says meaning I don't know how I don't have the value, right? And also if you're going to do that, then you need to consider, well, does that field allow null, right? If it doesn't allow null because it's been configured not null, then you'll get an error, right? Or right. It can accept a default value, right, for that. So here's a couple examples that where we're going to exercise this idea. We're going to, before we insert a couple of users here, we're going to insert a couple of blogs. Okay, so maybe we can find first the blogs that are already there. So find all blogs before inserting new ones, just to see what's there already. All right, so let's do that. I guess with the comments. Oh, I'm sorry. Did I skip over this? Right. Sorry. Before I go into that, right? Having done these, having demoed how to insert into users, we ask you, right? We ask you to you try it, right? You try it on your own, right? Create new blogs. Create a new blog about space. One called the Angry Astronaut, right? And one called NASA Spaceflight. Okay, both by Edward Scissorhands, right? So remember that when you insert a blog, if you remember blogs, right? Let's run the blogs. You'll notice that the blog has also the user, right? The user that owns that that blog, and so we want you to insert right into this table, into the blogs table, and the name of the blog should be called the Angry Astronaut, and the other one NASA Spaceflight. Okay, so it'll be the IDs, I presume, will be 9 and 10, right? 9 will be for the Angry Astronaut and 10 for the NASA spaceflight. And also the owner, right? The user ID for this will be whoever Edward Scissorhands was, right? I don't know who Edward Scissorhands turned out to be. So Edward Scissorhands is number 7, right? So when you insert into the blogs, right, the user ID here should be 7 for both blogs. Okay. All right, that makes sense. All right, so once you've done that, we can move on to the next one. And here we're going to practice inserting. I'm going to create a couple blogs, and one called E for electric, and the other one space eccentric. Right, one is for cars, and the other one is for space, where cars and space are presumably the topic of each one of these blogs. Right, so we can take a look at the blogs first. So there they are. These are all the blogs before we insert, and then we can insert a blog. Insert a blog, and then we can insert the other blog too. Let's insert that one about space. Sorry, about Tesla news. Okay. Let's paste that in there. Let's run it. So presumably we were able to insert those two blogs, and we can do the select and see the blogs that we just inserted. Hopefully, where'd it go? There we go. It's not showing my. Why is it not showing? Let me see. Users, insert, show the results. There we go. Okay, apparently I inserted space eccentric twice, one too many times. I inserted, I guess I inserted this, I ran this twice. That's fine. I inserted the blogs twice, that's fine. Oh, so there they are. So these are the two new blogs that I inserted. E for electric, and the other one space eccentric for the topics cars and space. Then we then ask you to do something similar. We ask you now. You try it. Find some content about Tesla and SpaceX. Right. So find some content, and then create a couple of posts. Okay, for each of the two blogs. Right, so in total, you're gonna insert 4 records. Okay, 4 records in total. 2 are gonna be posts about Tesla, and 2 are gonna be about SpaceX. Okay, and the 2 new inserts need to populate the following fields. The post. You can take a look at the old posts here. Right, if we can take at the posts, right, we can look at the posts. So the posts, right now there are 2 posts, and therefore blog number 2. But this one says, 2 of the new posts are going to be, for the ones that are about Tesla, are going to have the parent blog is going to be E4 Electric, right? And that's the blog that I created earlier, right? And the other 2 posts are going to be, the blog is going to be in the space eccentric blog, which we created earlier, right? Now the IDs for them, right? We just found out that the IDs are 9 and 10. See that? So when you do the posts, when you insert into these posts, make sure that these blogs, right, 2 of the blogs are going to have ID 9, and the other 2 are going to be 10, right? Because they're going to be 4 posts in total, 2 for SpaceX and 2 for E4 Electric, and 2 for Space Eccentric. That makes sense? So in total, you're going to insert four new records. All right, excellent. So the next one is that now the insert command can also be used for copying, right, data, right? So data that might be already there, you can retrieve that data, use that as a source, right, to then create new data, right, based on the old data, right? Sometimes it's referred to as copying, right? So for instance, the syntax for that insert command is that same thing. You say insert into a table, but then you can source the data from another table, right? You can say you're going to insert in table 2 whatever is already in table 1. Okay. You can also filter exactly which records you want. You might not want to copy the whole table, right? You might want to say, it has 1,000 records, but I only want to copy 50 of them, right? So you can put a condition that filters exactly which records you want to copy over. Also need to be careful that the fields, since these are 2 different tables, right? The field names might be different, right? The data types might be different. So you have to be careful that the data into the table that you're copying into, right, matches the data and columns that you're copying from, right? So you got to be careful there. So just to illustrate this, what we're going to do is that we're going to take a look at the posts, right? We're going to look at the post table, and in the post table, let's see, posts. Also for the posts, right, we have also a ratings, right? And the ratings tell us which posts people liked and which posts people didn't like, right? It has right here in this likes over here, we have 0s and 1s, right? Where people have either given thumbs up or thumbs down on a particular post. So what we're going to do is that we're going to create 2 tables. One is going to, we're going to copy in there all the posts that were liked, right? And in the other table, we're going to copy over all the posts that were unliked. Okay, so the way we're going to do that, first I'm going to do the unliked posts, okay, and you're going to do the liked posts, right? So what we're going to do is that we're going to create this table here called the unliked posts. I'm going to create a brand new table, copy it. And let's go, where were we? Right here, right? We'll create a brand new table that is not there yet, right? So I'm going to paste this in there. So this is going to be a brand new table. It's going to be called the unliked posts, right? Which is going to keep track of the post that was unliked, who unliked it, right? And the blog that this post belongs to. Also, who owns this post, right? The actual post and the blog name. Right? So basically, this is the pointers, right? The references to the original records, but also we're going to copy over the instead of the user ID, I'm going to copy the actual username of the person who owns this. And post is the actual post that people unliked, and what blog they belong to. Right? So I'm gonna just select this. I'm going to run this, and if I refresh, there it is, right? There's the brand new table. There's nothing in it yet. If I click on it, notice that there's no content there. There's no content. It's blank, right? So we're going to insert. We're going to copy from all these tables. We're going to copy the user from the user table. We're going to copy the post from the post table. We're going to copy the blog from the blog table. So we're going to source data from multiple tables, right? And then we're going to insert all this data into this brand new table we just created, right? So let's do that. So there it is. Right, so notice that we're going to into this new table that we just created. We're going to grab from these three, actually from four tables, from four different tables, right? We're going to join four tables. We're going to join four tables. The user because we want the username, right? The blog because we want the blog name. The post because we want the actual post, what was posted, what is it that people didn't like about, right? What's wrong with the post? And the ratings, we're going to know, we want to be able to find, those posts that were rated with a 0 or thumbs down. Okay, so here it is, the where clause here. These first three predicates are for joining those four tables, right? Here's the joining of the user with the rating. Okay, so we know who did the rating. Who is it that didn't like this? We are going to join the post with the blog, and we're going to join also the post with the rating. So we know which is the post that was disliked or unliked. And we don't want all the posts. We only want the posts that were unliked. So ratings.likes equals 0. So yeah, so these three queries, these three are for joining the four tables, whereas this one is filtering and saying, well, we don't want all of them. We only want the ones that are unliked. We retrieve all these fields. So we're projecting, right? We're retrieving the ID, the blog, the username, blah, 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 blah. Notice that we are renaming, right? We are renaming the fields from the ID from users. We're renaming it to user ID, right? The ID from the blogs, we're renaming it to blog ID. Username, we're leaving it alone. So we're just keeping the same column name. We're keeping the post same, and blog.name, we call it blog name. Notice that these names match the names of the fields in the table. See that? Right? Again, the data type and the names of the fields that we're inserting into need to match. Otherwise, I was going to say, well, you're having a username. It's called, ID, right? The user, the ID, right? And you need to tell me, where do you want me to put it, right? And it's for that particular column. All right, that makes sense. All right, so let's try it out. So I'm going to copy that and I'm going to run it here. Down here. So I'm going to run this. We run that. And if we go back to the unliked posts and we refresh, there they are, right? So these are the two unliked posts, right? That, SpaceX stinks and whatever. That are the posts over there, okay? So anyway, so this, just what we did, you're going to do something similar, right? But instead of unliked posts, you're going to do the liked posts, right? You're going to, I'm giving you a new table called the liked posts, right? So you're going to create this brand new table, which at first is going to be empty. So at first, right, it's going to be empty. So so if you run that, this is the liked post. So let's run that. And so let's see. Let's refresh. Why is this not creating it? Rows, blah, 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 blah. Unknown table, yada, yada. Yes, I know. I just created it. Oh, I know what it is. Let's see. There it is. So liked posts, and notice that it's empty at first. See that? It's empty. So what you're going to do is that based on this query, you're going to insert, right, into the liked posts, the posts that are liked instead. Make sense? All right, so fine. So that's all about inserting into the database, right? We then ask you to practice the use of the update table, right? So in the update table, like the name suggests, right? If it says update, basically is we want to be able to change data that is already in the database, right? So you have a whole bunch of records, we want to update them. And the syntax is as follows. You say, you update the table that you say which table you want to update. You also say what are the new values for which column, right? How do you want to modify? And then with the condition, the where clause says, well, which records do you want to change, right? You could change many records, or you can change an individual records, or God forbid, careful, you could change all the records in a table, and probably that's not what you want, right? You want to first identify which are the records, right? And then change whatever you want to change for those particular fields. So what we're going to do is that we're going to update the likes of a record whose ID is 5, right? And we'll change it from 0 to 1. So this is presumably a post that was unliked, and the person read it again and says, "Ooh, I actually like this post." So they click on the thumbs up, right? And changes their mind, right? So let's take a look at let's look at the ratings for a particular post. So let's see for post number 1. Ratings table liked. No, wait, I'm running this. Okay, there we go. All right, so for post ID, we have 3 likes and 1 unlike. So number 5, notice that it's the only unlike this post has had. So we're going to change that from unlike to liked. Okay, so what we're going to do is that we're going to update the ratings table, and we're going to modify the likes field. We're going to change it to a 1 for the ratings ID number 5. So this 5, right? We're going to change the likes from 0 to 1. So let's do that. Let's update it. Let's update that. So say run that. And we can do the query again to make sure that it has indeed changed. And indeed it has changed. See that? It used to be 0, now it's 1. Okay. So this now we're asking you to try it. You try it, right? Update the score for one of the records in the ratings table. Set the score to 3 for the record whose ID is 9. So it looks like here the score is 5. See that? So we're asking you to change that to a 3. Right? Change that to a 3. So instead of 5, it should be a 3. Right? So again, you're gonna do something like an update, blah blah blah, change the ratings from a 5 to a 3. Okay. Deleting a record from a database. So the syntax is as follows. You say delete from a table where condition. Okay. So where you can say, okay, so these are records that already exist in the database, and I want to remove a specific record or set of records, or God forbid, careful, right? You could remove all the records in the database, although most databases today will stop you. Will say, do you really want to do this? I mean, you have hundreds of thousands of records. Do you want to just throw that all out? Usually they'll stop you, right, and says no. It's configured to stop you from making that mistake. Because if you don't provide a where clause, then the interpretation is that you want to remove everything, right? Where, if you don't have a where, it means that you mean all the records, right? So careful with that. And so here we ask you to remove a particular rating with an ID of 2. So here's the ratings table. So we're asking to remove number 2. I believe I did already. Yeah, I already removed 2. Let's change that to, oh no, user ID 2. User ID 2. There it is. Okay, so this one, I guess, right here. Okay, so we can remove that. We can remove that particular rating. It's gone, presumably. Let's select it again. Let's see if it is gone. And it's not. Unknown column. Oh, okay, it's not user ID. Delete. Where's delete? User ID. I misspelled it. Ooh, okay. This is user ID. Good catch. Let's try it again. Let's run that. And then we can select it again. And you see that user ID is still there. What? Something on the post. Let me see on the chat. Is it possible to delete an entire column? And do you mean a column or a record? You can remove a record. You can alter a table. You can alter a table and remove a column, right? You can add a column. You can remove a column, right? But that would be changing the schema of the database as opposed to, so what we're talking about is removing records, right, that have been inserted, whereas columns, right, that's changing the table itself, right, where you can go and say blogs, and you can say alter the table. So the question is, can you remove a column? Yes, you can. You can go into alter, and you can say topic, right, and you say delete selected column, right, and this will create a oops. If I say apply, right, notice that it's gonna alter the table, and it's going to drop a foreign key. It's going to drop a column, and that's not what we want. I'm going to leave it alone. We're not going to change the schema of the database, right? We're removing records, data that we've already inserted in there. Okay. Yeah. Usually, changing schema in a database is considered, something very, very monumental. Okay, and it should be reviewed with a lot of folks, and since the database presumably was designed, with a lot of effort, and might have a lot of data that is relevant. So yeah, so that's delete. Anyway, so after you've gone through and you have all the steps, you should have about 19 steps in total. Inserting Edward, inserting Frank, retrieving all the users, then inserting the angry astronaut, inserting NASA spaceflight, inserting E for electric, blah, 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 finding all the blogs, inserting the 2 posts, right, for each one of the new blogs, then creating the unliked post table, creating the like table, populating them. So you should have a lot of these listed in your file, right? In this SQL file. So you should save it, save the file, and call it updating databases.sql, right? That's for this assignment, and then submit that as your deliverable for this assignment. Okay. Let's see. Okay, there's a question here. It says, for the we try and for deleting record, I'm a little confused because 3 seems to be the score, but then it says ID equal 3. Oh, is that why it wasn't working? Let's see, where you mean for this? You mean for this update? Or for the deleting the record? Deleting the record. Let's see. In deleting the record, let's remove all ratings from user 2. The ID 2 above doesn't, okay, feel free to, now you try remove all ratings whose score is less than or equal to 3. Oh, okay. All right. Yeah, no. Okay, no, never mind. I thought we were going to use the ID equal 3. I'm just going to say, if IDs don't work for you, feel free to fix them to ones that work. Yeah, no, I was just pointing out what I meant to say is that the IDs that I'm using here, number 2, number 3, all over have a whole bunch of queries using specific IDs, and the problem might be that when you import the database, right, into your MySQL, it could be the case that those IDs are not exactly what I was expecting. So instead of 2 or 3 or 5 or whatever ID I use here, if it doesn't work for you specifically, feel free to change them so that the IDs do work. Yeah, that's what I meant. All right, so that's the assignment. It's due in a week, so feel free to play around with it. Use the information that we gave you, and if you have any questions, ping me up at Piazza, and then we can work there. Any questions? All right, excellent. So let's move on. All right, so let's see. Okay, so let's do an intro I was supposed to say intro to the insert, right? So let's talk about insert or into, yeah. Oh, insert into. Okay, no, that's correct then. SQL insert into. Oh, no, so that's spelled correctly. Okay, yeah. So let's talk about insert. So most of what we need to know, we already covered in the assignment, right? So this should go a little fast. It's more a review of what we just talked about, but we'll talk about it in a little more thorough, and it'll be the formal discussion about insert, right? So insert, right, like the name suggests, right? Insert allows you to create new records in a table. And the syntax, right, the simplest of syntax is insert into the table name and then just values, value 1, 2, 3. Right? And here's a simple example, right? That we have a table that already exists, presumably called the persons table, and we're going to insert into persons the following values: Craig, Daniel, 2 Mill Lane, Drake. Okay, and there's the new record right there. All right. So yeah, so this is the simplest of syntax, right? Where you just provide the values, and then it assumes that 4 you meant for the person ID, Craig you meant for the last name, Daniel you meant for the first name, address, and city. Okay, so that's that. It does looks at the original description of what the columns are and the order and the data type, right? And does the mapping for you. Okay, so careful, right? Order of inserted values. So you have to be careful, right? That the order and the type of the values, they have to match. They have to match the original description, right? So 3 has to match the data type for B, and XYZ needs to match the data type for C, and so on and so forth, right? So the order is taken, the order and the data type of whatever you're inserting has to match the order and data type of the original creation of the table, okay? Also, you have to be careful if you omit values, right? So for instance, here we are inserting and we're giving a value for B, we're giving a value for C, right? And that's correct, that's fine, they maps nicely. Notice that it would have been a mistake if here, right, I would have said, 321.43, right? That would have given me some errors, right? Whereas it, because expecting bar chart. Right, so careful, right? The skipped columns, the ones that you're not providing a value for, everything's okay if that field accepts null, right? If it accepts null, there's no problem, right? If it has a default value, no problem. You didn't provide it, that's okay. I have a default value. But careful, if the field has instead been declared as not null and you don't provide a value, right, and it doesn't have a default value, okay, it's going to fail. It's going to say, oops, no, I do need a value for that. Okay, so for instance, here, right, so if you have a default value and you don't provide it, then it gets the default value, right? But right, so for instance here, since you have the float being the default 123.45 and you did not provide it, then it would get the default value 123.45. Now here, because you didn't provide it before, right? If you didn't provide it and there was no default, and by default, null is okay, right? If you don't want null, you have to specifically say not null, right? But by default, all fields accept null, right? So if you don't provide a value for D, by default, the value of D is null, not 0.0, okay, not 0.0, right? In programming, usually if you declare a variable as an int or float and you don't declare its initial value, right, you can assume that the compiler will initialize it to 0 or 0.0. Okay, you can assume that. Not here. If you don't provide the value for float or integer, right, it'll leave it null, right? Meaning I don't know what the value is. It's unknown, right? So it's not 0, it's not empty, it's null. Right here, if you provide a default, then it'll take that default. Right, now be careful, right, because you might have skipped over, right, assuming that I wanted the value for B, I don't want to provide the value for C. Instead, I want to provide the value of D, right? So you might have assumed that if I maybe some spacing or extra comma or things like that, it's going to fail, right? Instead, it's going to interpret the value for 543 as being mapped to C, right? Because of the order, right? Because of that order. So that's going to fail. So careful with that. If a column allows null, right, then you can skip it. You can skip it by just providing the value null, right? It says I don't have a value for C, right? And so you can skip it if you are providing the value of null. Again, that's if the column allows null. But if it doesn't support, if it's configured to be not null, right, you'll get an error. Okay, so we looked at the syntax, the simplest syntax, which is inserting. You just provide the values, right? And you don't provide the names of the columns, right? So there's another syntax that we also took a look at just earlier. So in this alternative syntax, you are providing the names of the columns, and what you would expect, right? The values are going to match the order of the columns that you provide. So this value 1 would be for column 1, value 2 would be for column 2, value 3 for column 3, and so on and so forth. So now the ordering and the data type is not dictated by the original declaration of the table. Instead, now it's dictated by the columns that you list here. Okay. And now, because you're telling me the columns that you're using, right, the order doesn't matter, right? I could move column 1 down at the end with value 1, and I can give them to you in any order you want because you're saying which column are you populating. Okay, so it's totally fine if this would have read, column 2, column 2, column 1, column 3, or column 3, 2 and 1, right? You can flip them around, doesn't matter. Right, obviously the values would have to also move, right? So yeah, so you can move that around. And so here's an example. We are inserting into persons Edward Norton here, and we're only providing the value for the first three columns, right? And notice that we are leaving out address and city, so these presumably would be null, okay? And 5 is for the PID, Norton for last name, and Edward for the first name. Okay. So now the order and the type must match, right? So as we said earlier, right? So the data types and the order is now dictated by the columns clause here, right? It's just to be consistent. And if you skip, obviously skipping columns here is much easier, right? You just don't list it. Just don't list the column, and the column, if the column accepts null, right, or it has a default value, then those will be triggered, right? But if you're skipping and it's configured to be not null, right, and it doesn't have a default value, right, you'll get an error. And so careful with that, right? So here's a couple of examples. Notice that we are declaring table A here has B as an integer. C, these are all integers, right? So B is integer. C is also an integer, and it's the only one who has a default value. D has an integer, and E. So all these are integers, right? But now here we're providing only values for B and E. B and E. So for B, I'm providing the value 1, 2, 3. So in effect, I'm getting that. How about C? C, I didn't provide a value for C, right? So it's going to get the default value of 2, 3, 4. For D, I also did not provide a value, okay? So it's going to get the value null, right? I don't know the value of D because you didn't give it to me. Whereas E, I explicitly set it to null, so it's set to null, okay? What would have happened if any one of these would have said not null, either this one or D, right? Then you would have gotten an error, right? Because I don't accept null. No, you can't insert a record with not null, right? But you can configure that, right? So how about this, right? It says now let's try it. How about not null? Well, if you configure D now to be not null and you skipped over it and you didn't give me a value for D, and I don't have a default value either, right? I don't have a default value. This is going to give you an error. You're trying to insert a record that breaks this constraint, right? The record cannot have null for D, right? If there would be a default value here, everything would be okay, right? Because you're not giving me the value, and I'll default to whatever the default value is, like I did with C, right? But here you're saying that it's required. You're not giving me any value, and I don't have a default value, so I'm going to stop you. You cannot insert that record. Okay. Question: if you put null for C, would it be 234? No, it would be actually null. You're overriding that, and you're saying that you want it to be null. Yeah, you're overriding it. If you don't provide the value at all, then it'll default to 234. Not null and default value. So here, for D, right, we are providing the value. If a column is not null, then you must specify the default value or provide it in the insert. Like we had here, right? So the way to fix this, right, is to, you don't want to provide the value of D. I can always give it a default value, and there it is. And now, now my original insert would have worked, or I can just go ahead and actually provide a value for D, right? So those are two fixes, right? All right. Okay, so let's take a look at insert into select. So this is the example that we saw earlier, where we can copy, right? We can say, hey, we have a whole bunch of tables out there. Maybe we can use it to generate. We can use that as a source of data to generate data into another table. Okay, so for instance, so the sometimes we refer to this as copying, right? Copying data. And the syntax is as follows. So you're going to insert into another table, right? And sometimes we might call this maybe a target table, like a target table. So we're targeting that table, and then we are reading from some source table. The source, might we call it source table 1 and source table 2. So two tables from which we are reading data. Right, and then we're going to put the data in a target table. Okay, so from if you have 2, 3, 4 tables, whatever, right? Obviously, these need to be filtered, right? And says, well, which records do you actually want, right? If you don't have a where clause, remember what you're going to get is a cross product, right? All the combinations between two tables, and probably that's not what you want, right? So more likely, you'll have to join the tables, right, and identify which records go with which record, right? So this will be some kind of join, right? Identifying the actual records you want. And then right before putting it into the target table, you have to make sure that the columns match, right? So maybe this should say, T1, C1, right, as you need to rename it, making sure that the target columns match, right? So this is maybe C3 as, just to remind you that if the source table, the fields, the field names, the columns don't match the target table, you have to make sure to rename them, right, using as, right? So to rename them into the columns for which you are targeting. If the source table already, the columns already the name and data type of what your target table is, then you can leave it alone. You don't need to rename it, right? So here's your C3, we are renaming it to column 3 because the target table column is column 3, right? You have to make sure that those match. Also, data types have to match, okay? So here's an example. So here's a table that we created called the alumni table. And so the alumni table, we want the name of the student, the ID of the student, the graduation year, the grad year, not drad, and the major where they graduated. Okay, so we're going to insert into this brand new alumni table. Okay, notice that we're making sure that the the fields that we're inserting to match the table, right? Because you have ID, name, major, and graduation year. So we need to make sure that those names match when we're inserting. And the data, we're going to grab it from two tables. One is the students table, and the other one is the departments table. So we're going to grab the student name and the ID of the students, and the graduation year, we're going to grab them from the student table. And we're going to grab the department from the departments table. Okay. And here is our join. We're joining the two tables. And then here's a filter of saying, well, we don't want all of them, right? We want the ones whose graduation year is in the past, right? Meaning they've already graduated, right? So their graduation year is not in the future. Okay, so compared to today, grab me the year, right? If the graduation year is in the past, then I want that. I want that user, right? That student, and I want to insert it into the alumni table. Make sense? All right. Let's see. All right. Just to reiterate here, we have to make sure that the columns that you are inserting, they have to match, right? The target table. So we need to say from the source tables, you need to make sure that you rename the fields, right, to match the data type and the order and the names, right? Let's see. So the question here says, what happens if they don't match? Yeah. So what we did here in this example, right? If you come in with that the original source table, the field was called C1, you can rename it using the as keyword, right? So that you rename it to the target column that you want to insert into, right? That's what we did in the assignment. In the assignment, the unliked post is expecting the fields to be called post ID, user ID, blog ID, and username, right? So this post ID is going to come from a source table. Where we're going to get that? Well, it's going to be the ID field in the posts table, right? And so here's where we rename it, right? So notice that these three right here, if we don't put the as here, then that means that all these three would come back. The name of the field would all be called ID, ID, and ID. See that? Right. That select retrieves the three fields are called the same. Right. If we grab that, we copy that, and we bring it over here and we run it. Okay. Okay, so if I don't have the as, so let's take out the as. Okay, I need commas here. And we run this. Oops. Oh, I didn't need to do that. So we run that. Notice that the three fields are called ID. See that? ID, ID, and ID. Because that's the original names in the original tables. Yes? But you can rename them by putting the as, right? As, right? As. I'm making it all capitalized because for me it's easy to read, right? But I remember that SQL is not case sensitive, right? So if you run it again, notice that now the field names are called post ID, user ID, and blog ID, right? And that's exactly what we're doing here, right? In these slides, right? What we're doing here is that this, me reminding you, right, that the target fields, right, need to match, right? And the way you do that is using the as. Does that make sense? Okay, right. So insert columns must match the target, and that's what we're doing here, right? So notice that we have a there's select, right? And I guess I didn't put the as here. So this is as A, as B, as C, and as D. Right, so from the source tables, X and Y, right, the fields in X are called XE, right, or F or G or H, and you can rename them using the as, right, because the table, it's expecting A, B, C, D, right, and so you're inserting into A, B, C, D, and this is how you're renaming the fields, okay? Right, you can also just copy a single record. Up to this point, right, these were just copying wholesale multiple records from multiple tables, or you can just do one here, right? So here's a copying a student, and it might be that you have a student that they're going to be in the same graduation year, they're going to be in the same department, they're going to be they're in the same course, everything, right? And you can copy a user that you might know, right? Student ID number 1, right? And then here we are renaming the fields, student name, right, major ID, and then we're inserting into a student, basically copying a student, but we are giving them obviously a different username, right? So maybe we're copying Scott, right? And we want to copy everything about Scott, but into a new user, and we just maybe change just the name of the user and call it Dan. All right. You can also, right, there's another alternative syntax where instead of doing this, right, these are 2 steps, right? Here we created the table, and then we insert into that table, copying from another table, from other tables. Yes. Now you can actually merge these 2 instructions, right? These 2 commands into one single command. So instead of using this insert right here, you can create the table, and you can merge it with select, right? So the syntax is called create select. Instead of creating and then insert into select, you can just say create select, right? So let's take a look at that, right? So in this syntax, you say create the table, you give it the target table, right? So it's going to copy into that table, it's going to create a brand new and with the data that you're going to grab from whatever source tables you want. And the fields are going to be created on the fly with whatever the names of the fields that you give it here, the data types of those fields, right? And this is going to be a wholesale copy. It'll create a table for you from scratch. Pretty cool. Very, very powerful. Again, this is if you want to create like reports. Well, if you want to do reports, probably you'll use views. Okay. Also, they're useful for. So if you remember when we talked about views, we talked about that they could get expensive, right? They can, in the sense that when you run views, they are always executed brand new, right? Even though they're treated like tables, they're expensive, because you have to actually execute the actual select statement and regenerate all those records, right? So you can improve the performance. With a technique called materialized views. So materialized views, if you know that a view that you query a lot, right, and it has these select statements and maybe even nested select statements, and instead of running it over and over and over, and it has a nice report, it has a nice schema, right, a third-party schema, right, that is useful for a lot of users, but they don't want to use the underlying schema, right, and they're giving this, and you're using views for this pseudo schema, right, that is joining a whole bunch of tables and giving you kind of like a report. You can, if you know that that view is going to be mostly read only, right, where you're only going to be reading data, that you're not going to be doing any updates, right, and also if you know that this table it changes very slowly, right? It's a maybe an annual report, right? Or maybe a quarterly report, and the report is generated that quarter, right? And so it's not like you're generating every day and changes every day. So but a lot of people are accessing the data, right? They're doing a lot of queries against it. They're doing so. Instead of having, you can improve performance by, instead of having it as a view, and every time you run that view you have to regenerate that report, right? What you could do is you could use this instead. Instead of creating a view, right, you can create a table. You can create a table. This is a temporary table. You know that this is a table that is now a denormalized table, right? Because it's joining. You had split this table originally, probably because you were doing denormalization. You were denormalizing. I'm sorry, you were trying to normalize the database, right? There was some redundancy, and you decided to split these two tables, right? And so, but oftentimes folks want to consume the data in a denormalized way, right? Where there's, oh man, you split it into multiple tables. It's very cumbersome having to rebuild this. So this is a technique called materialized views that, it's denormalized, that is not correctly implemented. It's not meant as the core schema of the database. It's only for convenience purposes, right? And oftentimes these materialized views, right, you don't manually maintain these materialized views. You have algorithms that automatically make sure that the database still, there's no redundancies, and you programmatically go through the database and remove any redundancies and any inconsistencies. And this actually could improve performance. So we'll talk about improving performance using denormalization techniques. And usually you use it through some very well-known algorithms that deal with this, with these potential redundancies and inconsistencies. Anyway, yeah, so that's insert. Let's move over to update and delete. Any questions before we move on? All right, excellent. So let's move on. Let's talk about database updates and deletes. All right, so like the name suggests, right, we're going to be talking about how is it that we can update or delete data from a database, right? So, and delete, like the name suggests, basically is you want to identify certain rows, right, from where you want to remove from a source table, right, from a target table, right? And it has two syntax, right? One of them is delete from table, right, or delete star from table, and then, but you have to be careful with the syntax, right? If you don't specify the where clause, right, the where clause, then it'll try to actually remove all the records, right, from that table. So usually we use this syntax, right, where you provide a where clause that filters and allows you to identify exactly which rows you want to remove, right? This does not remove columns, right? You're removing a column changes the schema. This was not changing the schema, right? It's just manipulating the data that is stored in that schema. So here's an example where we are removing data from, we're removing Edward Norton. So here's Norton that has last name and first name, right? Edward and Norton, and then no longer Edward exists, right? In the resulting table. Okay. Now you can also mix and match the delete with nested queries, where you can have some sophisticated predicates, right, where you can calculate exactly which fields or which records you want to remove, right? So for instance, in this case, we are retrieving all the enrollments, right? For instance, we want to identify which users are not enrolled, or which sections, right, don't have any enrollments, right? So you might have certain sections open, but no one enrolled in it. Right? You have all these students and they enrolled in section 2, but nobody enrolled in section 3. Okay, so I would like maybe to remove, all those records from the section table that have no enrollment record in the enrollment table. So here I'm retrieving, all the section IDs that do have an enrollment. Okay, so I get all the IDs. And not in says, okay, well, compare all the section IDs of all in the section table. If those IDs are not in the list of sections that are enrolled, then I want to remove them, right? So I want to delete from sections those that have no enrollment. Okay, so you can make this predicate as complex as you want to identify exactly what it is that you want to remove. Okay, all right. So the update statements. So delete removes the records, whereas update, right, looks at records that are already there, and then allows you to modify certain fields, the values of certain fields based on some criteria. Okay, so the syntax is that you update a table, the table name, and then you can have any number of set, right, name value pairs, name value, name value, name value with a comma separation, right, and where you're going to update those tables and those fields with the new values. And you can identify which records, right? Because there might be thousands of records. Probably you don't want to update all 1,000 records. Maybe you identify a certain subset, right? A few dozen records that meet this criteria, right? And you got to be careful, right? If you don't have a where, just like in the update, just like in the delete, if you don't have a where, the delete removes all the records in a database. Well, usually databases will stop you from doing that, right? But in the update, same thing, right? If you don't have a where clause, you have to be careful. It's going to update all the records, and probably that's not what you want, right? So you have to identify exactly which records are the ones you want to update. So, for instance, here we're updating Edward Norton, right? We are giving Edward a place to live. And at first, there was, Edward was living in the streets, and so here we're setting the address, right, to 45 Groton Road, Lowell, where last name and first name are Edward Norton, right? So there we go, right? So we have the records have been updated. Okay. Omitting, yeah. So careful, right? If you omit the where clause, if you don't put the where clause, it's just going to go and try to update all the records, and probably that's not what you meant, right? Here now, since we have no where clause, right? Notice that now everybody lives in 45 Groton Road, Lowell, right? And probably that's not what you meant. So here we are modifying the graduation year. Maybe somebody here they decided to switch career, and they were enrolled as a chemist, and they decided that there's more money to be had if you are in computer science, right? So here's a student that, or maybe they close a whole department, right? They close an entire department, and so we need to switch over all those students over to another department, right? So here we're taking a look at all the students whose major ID is 20, and for whatever reason, it's closing down, and we are switching you over to a different department. And because of the overhead and all the pain of switching over a career, right, we say that, oh, well, it'll take you another year to graduate, right? So we're going to also set the value of the old graduation year. We're going to increment it by 1. So this is actually pretty cool, right? This is another a feature where the value of the new field can be written in terms of the current value, right? So you can increment it or make rules based on previous values to calculate the new one. So that's pretty cool. Okay. All right, that makes sense. Any questions? All right, excellent. Let's move on. All right, so let's okay, let me see. Question in the chat. Is setting major ID to 10 arbitrary? Well, yes, in this case, we are we decided to switch you from one department to another. So yes, it is arbitrary. Yeah, so I did want to revisit group by. So we did cover group by a bit, right? So, but there's some considerations that I want to make sure that you're aware of. Some things that you can't do in group by that I want to make sure you are familiar with. Okay, and this depends on understanding how group by works underneath, right? That certain things occur in a specific order, and because of that, right, there are certain limitations to the use of group by, right? Yeah, so let's first revisit how group by works, right? So the idea is that group by is going to, you can provide a field, right? And then you can group by that field. And what it'll do is that it'll create a bucket, right? For which if the values are the same, right, it'll go through all the records, thousands of records, and you're grouping by a field. It'll check to see where those records have the same value for that field. If they have the same value in that field, then all the records that have the same value are going to be in one bucket. Okay, so if you have 1,000, say you have 1,000 records, right, and you have 10 departments, and it's department 1, 2, 3, all the way to 10, and you group by department. And so, and you imagine if you have 1,000 students, on average you have 100 students per department, right? And you group by the department ID, then you're going to end up with 10 buckets, right? One bucket per department. And how many records in each bucket? Well, there's going to be about 100 records in each bucket, right? And so the question is, well, the resulting query, right, is going to return to you just 10 rows from 1,000 records. Right, it's going to return to you just 10, right? One per group. So in that one row that comes back, you have to somehow squish the 100 records, right, that was in each bucket. That needs to be aggregated and squished into a single row. So how is it that you squish it? That's the question, right? How is it that you aggregate those 100 records into a single row? Okay, I mean, what do you do with all the IDs, right, or the names or whatever, right? How do you collate and aggregate all those into one single value? So the point is that I'm going to try to make is that, well, not everything can be aggregated. Not everything makes sense to be aggregated, right? Some things make no sense to aggregate, right? So let's see what those things are, right? So first, let's revisit the syntax, right? You say select a column name aggregation functions, right? But before we understand this select, okay, let's take a look at the group by. Okay, all right. So here you have a group by, and you have column names. See that? So one of the first things that we need to consider here is that the only fields that can be put in the select clause, the only fields that can ever be here in the select clause are either fields that are in the group by, right? Fields that are in the group by. So there it is. So if you're grouping by multiple group columns, then those can be listed here, right? So if you're grouping by ABC, then they could certainly be here, ABC. The other columns, if you have C, D, E, and those are not in the group by, well, those cannot be listed here. They can be aggregated, but they cannot be listed on their own. Okay, right? And the reason is that if you have 100 records that need to be squished into a single result, okay, well, for field A, right, you have 100 values of A, right? If you grouped by A, all those values are the same. Yes? If you group by A and B, then again, you'll have a group that has the same values of A and B, that goes into a group. And for another value of A and B, that goes into a different group. Right? And for those within that group, A has the same value and B has the same value. So it is okay to list here those columns, A and B, because they have been squished into a single value, right? Because they all have the same value. Make sense? Okay. But what about the other columns for which I have not grouped by? How about, fields C, D, and E, which I did not group by? Yes? Well, for values, for those other fields, C, D, and E, I have 100 values of C, 100 values of D, and 100 values of E. How do I squish that into one value? Okay, because there are different values. Right? In a group, in a particular group, the values of the other fields, they might have multiple different values. So the only thing that, and they have to, how do I go from 100 values to a single value? Right, where they need to be aggregated. Right. However, I decide to aggregate, right, I can decide that, field C, I'm going to count how many there are. The other one, I can calculate the max. The other one, the minimum. The other one, the average, whatever, right? But they need to be, those 100 values of each one of those fields needs to be collated or aggregated into a single value, right? But, it would make no sense to put here other columns, right? That would make no sense, right? Because again, each one, you have 100 values here, right? There's 100 values. So I'm going to put here a text. I'm going to strike through, right? You cannot have the other columns. They need to be aggregated, put inside of an aggregation function, right? So let's take an example, right? So let's take an example. So here we have an orders table, right? In orders table, you have customer Alice, Charlie, and Bob. And you'll see that if I group by customer, right, then Alice, these three rows would be in the bucket Alice. And these two, the Charlie and Charlie, would end up in the bucket Charlie, right? And then Bob is all by himself. So at the end, I end up with 3 buckets, okay? In those buckets, the order ID, right, that for Alice, I have 3 values, 100, 700, and 300. For Charlie, in the Charlie bucket, I have 1600 and 100. And in the Bob bucket, I just have 2001 value. Okay. So in the Alice bucket, right, in the Alice bucket, I can say select customer. I can say select customer because I grouped by customer, right? Because there's only, and the customer that's going to come out is just has 1 value. But I could not say select customer, comma, order price, because for order price, I have 3 values, 1 for this one and then these 2. So those need to be aggregated somehow, right? Because I did not group by order price, I grouped by customer. So I cannot just say customer, comma, order price. I need to aggregate order price. Do you want the maximum order price, the minimum order price, the average order price, maybe the sum of the orders, maybe? What is that you want to do? How do you want to aggregate order price? Understand? So it would be syntactically incorrect to say, select customer, comma, order price, group by customer, right? Because for order price, that would be 3 values, okay? So here it is, right? So we can calculate as follows. I can say customer, comma, order price. I'm sorry, sum of order price, or any other aggregation. I can count how many order price there are. I can average. I can say min, max. There's a whole bunch of aggregation functions, right? But it would be erroneous. I could not say order price here. Right? That would be a syntactical error. Okay, so I'm going to put it here, text, right? Syntactical error. So I'm going to strike it through. You cannot do that. Now you get an error. Okay. Because imagine if I would try to do that, right? And I say insert a column on the right. If I say order price, here, what would I put there? Right, the database would say, well, I don't know what to put there. You have, for order price, for this result, right? For this first result, you have 3 values, right? You have what? You have 1,000, right? 1,000, 700, and 300. So you have what? 1,000, 300, and 700. So is that what you want? All 3 values in there? What about if these are hundreds or thousands of records? You want 1,000 results here? That makes no sense, right? So that's why we don't, the database doesn't allow you to do that, right? You can't do that. So I'm going to just strike this through, right? So don't do that. It's an error, okay? String. There we go. Okay, yeah, so all right, yeah, so for instance, omitting, so okay, so we took a look at this, right? What happens if you do aggregation, right, but you don't have the group by, right? The database considers the entire table, as if it were one big group, right? So what it'll do is that, right, it'll give you the since you haven't grouped by customer, all right, what happens is that now each one of these is its own group. So Alice is its own group, Charlie is its own group, Alice again is its own group, right? And the value, right, gets the same value that all the results get, right? The sum order price. Okay, and oh yeah, so you can also group by multiple columns, right? For instance, group by customer and order date. And what that means is that instead of checking to see if the same value occurs multiple times for a customer, and that's a group, now it looks at the combination of 2 fields. If those 2 fields have the same value across multiple records, then they fall in the same group. Okay, right? So if you say Alice, says it's Alice, and then the date is February, right? So that is a group. But then Alice and March, that's another group, right? So you can group by just customer, right? So that means that all the dates doesn't matter, okay? But if you group by customer and you group by date, then you get a different group when you have Alice and February. All the orders in February for Alice, that's one group. And then Alice in March, that's another group entirely, right? So it depends. A query might be, give me all the orders for the year by customer, or the question might be, give me the orders by customer by month, right? If it's by month, then you want to group by customer and order date, or maybe there's a month here, right? So if it's yearly by customer, then you can just group by customer, or if it's monthly or weekly, right? You can group by the date as well, right? So here's another example as using other aggregation functions. Again, there's average, minimum, maximum, count, right? Sum, right? So those are the 5 most common aggregation functions, right? So here's a minimum and maximum, and grouping by, taking a look at the graduation year. Again, here we're grouping by the major ID, right? And graduation year, you haven't grouped by major ID. And by major ID, students might have multiple graduation years, right? You're graduating in 2021, others in 2022, 23, 24, whatever, right? And so in a group of 100 students, right, or 1,000 students in a particular department, we're all going to have different graduation years, right? But all in the same bucket. So what do you do with all those values? We need to aggregate. So here we're aggregating using min and max. Also, if you don't provide the as, right, the name of the resulting field, right, the name of the resulting field will be based on the function, aggregation function. So it's good practice to rename it to something meaningful, right? Like for instance, minimum year, maximum year, right? So that the field is readily available. So okay, let's look at some limitations. let's look at some limitations on what can you do and what you cannot do with group by. So the limitations of group by stem from two facts, right? Stem from the fact of when is the group by computed? Well, the group by happens after the where clause, right? Right. So first of all, you do a cross. Say you have multiple tables, and the tables, right? You identify all the records, and you do a cross product or something, and you say, well, these are thousands and thousands of records, right? That you need to consider. Now, the where clause identifies, says, well, out of the 1,000 of those records, I only want these 100 records. Yes? Okay. After we have identified what are the records that we're going to consider, then the group by runs, right? The group by happens right after we have filtered, right? Out of the 1,000 records, we have identified a subset of those records. Now we're going to group by. You say, okay, well, identify these 100 orders, right? There's thousands of orders, right? I've only identified these 100 orders, and I want to group by customer. Okay, now I can identify, well, these 100 orders, 30 are from Alice, 30 are from Charlie, and and 33 are from someone else. Okay, whatever, I don't know. Does that add up? 36, right? Goes to someone else, right? I've identified 3 buckets. Okay, so but this happens after I have filtered out what records I want. Okay, now after the where runs, the order by runs, and then last the select happens. Right now I have the 3 buckets, and I have the 3 buckets, and I can say, okay, well, I since you have group by customer, I can select customer, right? Comma, any other fields you've grouped by, plus an aggregation of all the other fields, right? I can aggregate all the other fields. Okay, right. So this is well, obviously this is how we know it works, right? But because this happens, right? There's some limitations. There's certain things that you cannot do, right? So consider the following. Consider something we would like to be able to do. So remember we had way back when we wanted to calculate the number of A's per section. Remember that, right? And we calculated as follows. Okay, so you have the enrollment table, and we are filtering and saying, give me only the enrollments for which there was a letter A. The grade was A. Okay, and you might have, in one section, you might have multiple people having A's, right? You can have, in section 1, you might have 10 people having A's. In section 2, you have 3 people having A's, blah, 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 right? So we're going to group by the section. You're going to say, okay, well, section 1, how many A's? Section 2, how many A's? Section 3, how many A's, right? So we can do that, where we can count in the buckets, in the section buckets, we can count how many enrollments there are, and that tells me how many A's there were in each section. Everybody good? Okay. I can now, that result, I can use it again to aggregate the whole table and just count and see, well, what are the maximum number of A's, right? Because section 1 got 3 A's, section 2 got 5 A's, and section 3 got 10 A's. So it comes out to be that the maximum number of A's is 10, okay? Which would look something like this, right? So you have your section 1, 2, and 3. Section 1 got 2, section 2 got 3, and section 3 got 1. So after doing these aggregations, it comes out to be that the maximum number of A's is 3. Now, imagine I want to now ask, my following question is, well, which section get the highest number of A's? Okay, which section get the highest number of A's? Well, somebody might say, well, oh, that's easy, right? I got my select max Q of A's, right? This is so this Q83 is this right here, right? When I group, it gives me that this 3 over here. See that 3? It would be nice if you could tell me also that it was section number 2. Correct? So it would have been nice if here I would have been able to also come back and say, oh, well, not only give me the maximum number of A's, give me also the section ID. And that would have said 2, 3. Section 2 is the one who got the highest, but you can't do that. That's an error. That's a syntactical error, right? I want to be able to say, right, select max Q as max A, comma, give me the section. So I know that it's a 2. That's an illegal. That's illegal. I can't do that, right? I cannot do that because I have not grouped by the section ID, right? This query is not grouping by the section ID. See that? Because I am grouping what? I am grouping the whole table. The whole table is a group of which I am aggregating and I'm returning this 3, right? So it's a syntactical error to add something here, which is not a group. Okay, that's an illegal query. So somebody might say, oh, wait, what about if instead I use the, I can maybe use the aggregation on the where clause and filter. I only want the sections, right, whose number of A's is equal to the maximum number of Q's. This is also illegal because the aggregation can only happen after the where, right, not before, right? So I can't do a where clause. I cannot put this aggregation in the where clause because I haven't yet identified the fields, the records that I need to aggregate, right? I need to group. So because remember, the group by happens after the where clause, right? So I haven't yet identified the fields. Like, how could I aggregate if I haven't yet identified what the records that I need to aggregate? And whereas here, right, the problem with this is that I can't, I don't have this value anymore, right? Because in the group, I have 3 values for section ID, 1, 2, and 3. Just like I mentioned earlier, right? Just like I mentioned earlier here, the order price was not in the group by, so I get 3 values. So same thing happens here, right? Same thing happens here. If I put section here, I would get 3 values for section. I would get 3 values for section. I would get 1, 2, 3, right? And that's not. I don't have. This 3, which one did it belong to? Did it belong to section 1? Did it belong to section 2? Did it belong to section 3? I don't have that anymore. Okay, so what to do? What to do? So there's a fix for this, and this kind of a hack, right? And the hack is that what you can do is join these 2 tables. If you join these 2 tables, you can join and say, oh, 3, I can match with this 3 here. I can join these 2 results and then come back with section ID. That's exactly what we're doing here. We're joining the 2 tables, the 2 results, the max A's with the number of A's, right? And then returning the section ID. But this is somewhat of a hack. A better solution is to use what is called the halving clause. So the halving clause is exactly what we want, right? It's a capability of allowing you to use the aggregation function in the where clause, right? Just exactly what we want to do here, right? We want an aggregation in the where clause, right? And that's exactly what you do. So you have a halving, and then the aggregation function and the operator, right? Where you can say, oh, I want the orders for which the price is less than 2,000, right? All right, I'm over my time, and we'll finish this up next time around. All right, everybody, thank you.
Thank you.
Bye-bye.
Thank you very much, Professor.
Thanks.
Cheers.